And now we'll just review our solubility rules. And I'm going to emphasize review here. This is absolutely something that in prep chem you were expected to learn and know. So we're just going to do a quick review because I do expect that you did cover this in pretty severe detail in prep chem. So we know with our precipitation reactions that, we take our ions, we take our other ions, we mix them together, and if something is insoluble, it will precipitate out. And so we can look at our solubility rules to figure out what might come out of solution. And so from our solubility rules, we know that our group 1A compounds are soluble. We know that our nitrates are soluble. Therefore, potassium nitrate is soluble. Now, we know that most of our halides are soluble. However, there's a few exceptions, and lead-2 happens to be one of those exceptions. And so this lead-2 iodide ends up being insoluble, and so it comes out of solution. Okay, and so this is what that reaction looks like. So I have a beaker full of ions. I have another beaker full of ions, and I pour them together. And we do get evidence of a reaction. We have this yellow precipitate that is forming, indicating that an insoluble product has been formed. And again, our lead-2 iodide happens to be our insoluble product. Now, if I pour a beaker of ions together with another beaker of ions and everything is soluble, I get a no reaction. So potassium iodide with sodium chloride, our potential products would be potassium chloride and sodium iodide, both of which are extremely soluble. So nothing happens. We consider that no reaction. So if you don't remember solubility rules, here's one chart. You can also go back to, whatever you use during prep chem, but you do need to know these. This is one of those things, I'm not a big fan of rote memorization for the sake of rote memorization. Things that I feel you need to memorize are things that are very practical that will come up, such as knowing your nomenclature. That's really important. Solubility is also really important. When you are working in a lab, it's really, really good to be able to understand what you are working with. Maybe you pour some stuff together and what you know about that should not form a precipitate. But all of a sudden you have a precipitate forming. That can give you a lot of information. Maybe one solution is contaminated. Maybe your glassware was contaminated. All right? Or maybe you pour things together and you expect to find a precipitate, but you're not getting one. Maybe something else is going on. So it's really, from a practical standpoint, from being able to troubleshoot what's going on in the lab, knowing your solubility rules is very important. So I'm just going to do a couple quick practices here. All right. So from here, using your solubility rules, I want you to see if you can figure out which of these compounds would remain soluble and which compounds would precipitate out. Okay, so pause and I want you to try this before I give you the answers. Because again, this is stuff that you should know from your prep chem class. Okay, so potassium with sulfide. Solubility rules tell us that our common sulfides are insoluble except those of group 1A metals, which potassiums are group 1A. So this would be soluble. And I don't know what my program is doing. Let's try that again. It's been unusually sensitive during this recording session. Or maybe it's my iPad. All right. We have a strontium ion and a chloride ion. All right. Well, we learned from solubility that our common chlorides are soluble. There are some exceptions, and if we look at the exceptions, strontium is not an exception. So this would be soluble. Okay. Calcium and carbonate. Our carbonates are insoluble, and in fact, if you know calcium carbonate, it's marble. So this is insoluble for calcium carbonate. All right, and then silver chromate is also insoluble. Okay. All right. And then here, I want you to try it the other way around, figure out if it's soluble. And if it is soluble, split it into ions. Okay, so again, I want you to pause and try it yourself first. All right, let's see how you did. Ammonium hydroxide, yeah, this one's soluble. So you're going to get those 2 ions. Iron 3 phosphate, that is not soluble. Okay, lead 2 acetate, soluble. Silver nitrate, also soluble. Silver nitrate, you have to be careful with this stuff. We store it in dark plastic or amber bottles because it is UV reactive and it will start turning dark. And in fact, if you get silver nitrate on your hands while you're in the lab, you're not going to notice it right away. But then when you go outside and the sun hits it, you'll end up with splotches on your hands where the silver nitrate hit it. It's from the silver that's in it. All right, and then barium carbonate, also insoluble. Okay, so if you struggled with these, you definitely need to go back and review because you absolutely are going to need to know your solubility rules. So hopefully these were easy. Hopefully. All right, and that's our review on solubility and precipitation.